Okay, now let's start 2020 question from 2020. All right, 14th MCQ from 2020, is it? Yeah, from 2020, 14th MCQ. Right. Water rises in a long vertical capillary tube up to a height of 2 centimeters. When the tube is inclined at an angle of 60 degrees with the vertical, what is the length of the water column in the tube? What is the length of the water column in the tube? Right. Okay. So this is something we have done before under pressure. So we have a capillary tube which is vertical. When the capillary tube is vertical, they are saying there is a rise of water up to a level of 2 centimeters. Is it 2 centimeters? Since it's a capillary tube, even 2 centimeter height is significant. Right. So let's quickly start. Hold on. Yeah, vertical height of 2. So this height is 2 centimeters. Take this as h1 equals to 2 centimeters. And we know capillary rise, it's based on pressure difference and all. Now they are saying they are going to change the angle of the inclination of the tube is 60 degrees with the vertical, right? So when you incline it 60 degrees with vertical, what's going to happen? That's the question. What is the length of the water column in the tube? Right. So let's tilt it by 60. Okay, Ibrahim. What about the previous? Okay, we'll wait, Ibrahim. I'll come back to that. Wait. Okay, so if you tilt it by 60, you tilt it by 60. Is this the correct question then? Is it from 2020? Is this correct? 2020. Oh, okay, then I think I made a mistake in the year. What is this question then? Here? This must be 2021, I think, no? Yeah, this is 2021. That's a missed problem. Yes. This is 2021. This is 2021. Okay, this is 2021. This is 2021. The previous question was from 2020. Now, okay, sorted. All right, fine. Sorry. Okay, that's a mistake. I think then our argument is fine. The earlier question, we'll come back to the earlier question. Wait a minute. Now people, hold on. This one, now we have tilted it by 60 degrees with the vertical, like this. So they're asking what is the length of the liquid column, and we know the same pressure has to be established. Now, people, the same pressure has to be established. Same pressure has to be established. So if that's the case, now they're asking what is going to be the new height of water. For what height will we have water or water? Yeah, okay. The length of water column. So we'll take this length. None of the other parameters are changing. Remember, none of the other parameters are changing. They have not mentioned anything about the contact angle and so on. Now we know how to handle this. Now, people, here it will be pi, and inside will be P. If you take this pressure as PA, and this pressure here will be PB, and this pressure will be pi. So let's assume that the contact angle is 0. If that's the case, we can say pi minus PA. Okay, pi minus PA is equal to 2T over R, and and the other thing here, you can say PB is equal to pi. Okay, PB is equal to pi, and the other thing is PB plus PB is equal to PA plus H1 rho G. So PB minus pi, PB minus not pi, PA is equal to H1 rho G, and that can also be written how? Pi minus PA. Pi minus PA is equal to H1 rho G. Okay, so this is we'll take this height as h2. We'll take this height as h2, and right, what I'm trying to tell you is here is this. Now these two pressures, when we equate these two equations, only we get that what do you call that final equation we will 1 and 2. When we equate, we'll be getting h1 rho g equals to 2t over r. So what I'm trying to say is this h1 is created due to that pressure difference 2t r rho g. This h1 is created due to all this pressure. So here nothing changes. Now if you take this point, it's pi. Here the pressure is pi. Here this pressure is like pb, and here the pressure is pi once again. Okay, and inside we can take the pressure as pa. It's this is the same thing. So all we need to do is we need to create we have to make sure this height is still what? This height is what? What is this height? We have to make sure this height is still 2 meters, 2 centimeters, sorry. Because we didn't change any other parameters. The atmospheric pressure, the pressure here will not change because the meniscus will not change, people. To change the meniscus, you need to change the liquid and the surface. So none of them were changed. So my point is PB here and PB here should be same. For PB to be same, this height, the vertical height, not this, not the length, the vertical height should still be 2 centimeters. So if this is 60, now we have a triangle. No, we can analyze. We have a triangle to analyze. This is perpendicular, and this angle is 60. This angle is 60, and then this is also 60. No, this is also 60, and this is 2 centimeters, and this is h2. Then what is going to be h2, people? We can say cos 60 is equal to 2 over h2. So h2 is equal to 2 over cos 60. That is 2 over 0.5. So h2 has to be equal to 4 centimeters. Right. So the answer has to be fifth one. That is how you have to handle this question. If not, you will have to do this again. You will get the same answer. But what you have to understand is when you tilt, nothing changes. The pressure is found based on this vertical height. That's all. So here we put h rho g, but here we don't put this h2 rho g in a way. This 2 centimeter into rho g. So what I'm trying to tell you is to maintain the same pressure, this height and this vertical height have to be same. So to maintain a 2 centimeter vertical height with the angle of inclination of 60 with the vertical, this length should be 4 centimeters. Then only you will get this as 2 centimeters. Okay, people? The answer for this question is fourth one, and unfortunately we had a mix up with this question. So 2021, it was the fifth answer, no, people? Is it okay now? Was it a fifth answer? 2021 14th MCQ? I hope it's fine now. Right. This is the 2021 question. And then if we go back to 2020 question, this should be 2020. A small error there. This is the 2020 question. Okay. Make it 2020. And let's discuss this quickly one more time. Figure shows a capillary tube dip vertically in a container of water with a large cross-section area. The system is fixed in an elevator at rest. So this system they have shown in the diagram is already in an elevator which is at rest. Okay. So when elevator is at rest. Now we know the equation for capillary rise. If you take this height as h, as a common equation, h can be written as h is equal to 2t cos theta over r rho g. So now what they are doing in this question is they are making the elevator move in two different methods, in two different ways. One is the elevator is accelerating downwards with an acceleration of 5 ms minus 2, and the other one is elevator is falling freely. So here they are maintaining t cos theta r rho, all of them constant. If all of them are maintained constant, then for h and g you are going to get a relationship like this. So g, we know it's 10, but g experienced by an object inside an elevator will change if the elevator has an acceleration. Okay, if an elevator has an acceleration, how does it happen? Now this is something we have done in mechanics. There are three scenarios we can quickly compare. What are those three scenarios? The first scenario is this. The first scenario, if the elevator is moving downwards with an acceleration, for that g should be considered as g minus a. I mean, not considered in the sense g, the gravitation acceleration experienced by an object inside the elevator will be g minus a. And the second scenario is what we go. Second scenario is when that object experiences an acceleration in the upward direction. So when you mark the acceleration downwards, it has two meanings. What is that? Elevator is accelerating downwards or decelerating upwards. This has two meanings. Elevator is accelerating upwards or decelerating downwards. So for this scenario, you will be taking g as g plus a. And for the third one, when acceleration is 0, that means the lift is at rest or lifting moving with a constant velocity, and during that time then the object will experience g as g itself, 10. All right, fine. So let's quickly analyze the two situations and finish this off. Roman 1, what is Roman 1? Elevator is moving downwards with an acceleration of 5 ms minus 2. Right, now there are, okay, so here when elevator is at rest, g is g na people, and it's 10 ms minus 2, and for that h is 8 millimeter. So here what happens, g should be considered g minus a, which is 10 minus 5, so it should be considered as 5 ms minus 2. Okay, so let's apply that equation for the two scenarios. First case, this 8 millimeter proportional to 1/10, first equation. Second scenario, that I'll take it as h1, that is proportional to 1/5. That's the second equation. So second one over first one will give us h1/8 equal to 1/5 divided by 1/10, that is equal to 2. So h1 is equal to 8 into 2, that is 16 millimeter. 16 millimeter. All right. So the answer for that should be what? Second one. Not second one. Sorry. It can't be first or third, because 4 millimeter not acceptable. Now the second scenario, Roman 2, it's interesting. That is, the lift is falling freely. The elevator is falling freely. What is happening there then? It has a downward acceleration of g. So there again g becomes g minus a. This time it is 10 minus 10 equal to 0. So people, g becomes 0 means, now what is the equation for h here? Now equation for h is 2t cos theta over r rho g. So when g is equal to 0, what is h? H is going to be infinitely large. H is going to be infinite. That means this water, according what this means is, this water will go up as much as possible. So this water has to go up as much as possible, and it will fill as much as it can. So if the maximum height it can go up is 40 millimeter people, they have given that as the answer. So the answer for this question is the fifth one. Answer should be fifth one. If it had been 100 millimeter, your answer will be what? 100 millimeter. If it was 120 millimeter, still 120 millimeter, because h has to be a very large value according to this equation. So in the previous tutorial there was a mix up because we checked the question in the wrong year and all those things, but I hope now it's clear. Okay, so I hope it's clear. There's nothing new. That's why I told you today we learned this equation, and this equation is important for you when you do MCQs. This equation, right? And we discussed how h changes with theta, how h changes with r. Here is an example as to how h changes with g, and the only way you can change g, there are two ways you can change g. You have to take this to another planet. If not, you can keep this object in an accelerating elevator. Answer is fifth. It can't be 0. Because h is going to be infinity now. So it will rise as much as it can. So final answer is fifth. Because h becomes infinity. Infinity and 0 are not the same thing. When will h become 0? When will h become 0? For h to become 0, no, h can't become 0 here because it already has risen. You can't make h. To make h 0, g has to be very large. So that's impossible, people. That's not possible. So yeah, anyways, this is how it's going to go. Fifth is the answer. Done. We'll move on to the next one. We're done with this. I think next we had to move on to 2019. 2019, this one is a question from the prototype paper, not from 2019. 2019, there is a question missing because there was a structured essay question from surface tension people for the very first time. Not for the very first time. In 2009 also there was a small part in surface tension, but 2019 structured essay was almost entirely based on surface tension. So we should definitely have a look at that as well. But anyways, let's discuss this question now. And this is a prototype paper from 2019 prototype paper. All right. Fine. What is this all about? If the mass of 25 water droplets of radius r falling through a syringe of internal radius a is simple m, the surface tension of water is given by. I think they have given this diagram to us as a reference. So using this diagram, we have to figure out something. Now they have given us the mass of 50 drops, people. Mass of 50 drops. Okay, mass of 50 drops. Mass of 50 droplets. No, 25 water droplets. Sorry, 25 water droplets is how much? M. Then what is mass of one water droplet? One water droplet. What is it going to be? M over 25. M over 25. M over 25. Yes. Now you have to understand what's going on here. I'll try to draw a bigger diagram here. People, what's happening is a water droplet is held at the edge of a capillary tube. If you think of this as the water droplet, I think some information are they missing here? Yeah, some information are missing. No. Here, if the mass of 25 water droplets of radius r falling through a syringe of internal radius simple a, careful. So wait, let me draw it properly and explain you what's going on here. Right, this is the edge of, this is the water drop, okay, and this is the edge of the syringe. This is the edge of the syringe. So I drew it a little bigger for you to get a better understanding. Hold on a minute. This is a really good question. Hold on, I'll make it a little bigger. Right. Syringe. Here we go. Syringe. Right. This is the syringe. The edge of the syringe. The needle part will be a little sharp on a people. That's why it looks like that. And remember, your syringe. It's a it's circular outlet, right? It will have a circular outlet like this. It will have a circular outlet like this. Hope you can agree with me. So that circular outlet is the one who is holding that, water drop. That circular outlet is the one holding that water drop. Like this. Does it make sense? Right. And water drop falls down because of who? It falls down because of who? Tell me. Why does the water droplet always try to fall down? Because of what? Come on. Why does the water drop fall down? Because of its weight. Because of its weight. Okay, it falls down because of its weight. So there will be a weight acting downwards, that is mg, not mg, we have to be careful. Mg over 25 is the weight. Mg over 25, not mg. Don't put mg over 25. And if for someone is preventing it from falling down at this point, or when it's about to almost ready to fall down, someone is preventing it. Who is preventing it? The this part of the syringe. So remember, the radius of the syringe is given as simple a. Don't forget that radius of the syringe is simple a, this length. So the force we just studied today on capillary force. There's no angle, it will be acting upwards like this. Contact angle is not given, so we can assume that the force acts along the wall of the syringe upwards like this. Got it? F. I'll take that as F. The F I'm putting here. Who is this? Can you describe this F? This is the F created by who? Surface tension. This F I have marked here is the upward force created by surface tension. Upward force created by surface tension. Right. Now, what is the equation going to be for this scenario? The scenario they have given in the diagram is the point where the water drop is about to fall down. About to fall down. So, let's start for equilibrium. For equilibrium, oh sorry. How many free surfaces are here, people? Only one free surface, no? Because, yeah. Then upward force has to be equal to downward force. Upward force is F equal to downward force is mg by 25. Now F is given by surface tension multiplied by the length along which the force is acting equal to mg over 25. Now we have to be very careful about that length. What is that length, people? For length, what should I substitute? Tell me quickly. For length, what should I substitute? For length, what should I substitute? Length is the length along which the force is acting. So what should I substitute for length? This is that's very important. For length, you will be substituting 2 pi a. Exactly. Very good. 2 pi a. For length, you have to substitute 2 pi a. 2 into, sorry, t into 2 pi simple a. Capital R is the radius of the water drop. That has nothing to do with that force. This is capital R. So there are answers which with capital R as well, no people. So you have to be double careful. And mass of the water droplets are given already, mg over 25. Question is, what is the surface tension of water? So final answer, T is equal to this, everything goes down, mg over 50 pi a. 50 pi a. Which answer? Fifth one, isn't it? Fifth one. This is a super cool question. So they have given you this diagram and they're expecting you to do this and figure out the answer. I hope that's clear, right? And we have to, we have to have a very keen understanding about what's going on here. So this visualization is quite important. Good, right? Done. And then we'll move on to the next question. This is something we discussed at the class as well. We did such examples at the class. So this is question 2018-22. They have given several soap bubbles which are in contact with each other, and we know the radius of the soap bubble will vary according to the pressure inside each bubble. So which one do you think is the answer, people? Before I start discussing, would like to know your answers, your choice for these questions. What about your answers? Right, good. So I have a few of them. Hikma, Hasnan, Yusuf, Faiz, they have already responded. They all think of the same answer, right? Zainab, Tawfiq also thinks of the same answer. Right, okay, let's start the discussion. Figures show 5 clusters of soap bubbles in air as drawn by a student. Student, if centers of the bubbles in each cluster are coplanar, okay, which of the following shows the cluster with physically possible correct shape? Right. So the summary is this, people. Just quickly put the summary so that it will be easier for us when we analyze it. The summary is this: when you have two bubbles like this, apologies, when you have two bubbles like this in contact, you have two bubbles like this in contact. All right. There are two bubbles like this in if there are two bubbles like this in contact, what you have to do is it will be not this line. The common interface between the bubbles will not be this line, neither will be this line, neither will be the line in the middle. What is the line in the middle? That is this vertical line. Okay, so these are the three things you have to compare with. So we can eliminate that as well. And where to? So how will it be? How will it be? That's the question. How will it be? I'll use a different color to mark that, and we know now inside this there will be a pressure P1, and inside this there will be a pressure P2, and the same pressure will be here P2. Same pressure will be here P2, and here we have same pressure, atmospheric pressure pi. Here we will have the same pressure P1, and here we will have the pressure pi. So we know we can write an equation like this: P2 minus pi is equal to 2t actually 4t over radius R2, and here we can say P1 minus pi is equal to 4t over R1. So simple R1 is smaller than R2. Simple R1 is smaller than R2. So you can say pressure 1 is greater than pressure 2. In other words, in the future, let's remember in an easy way, smaller soap bubble will carry larger pressure, and larger soap bubble will carry smaller pressure. So from high pressure to low pressure, there will be a push. Therefore, that the common interface will in fact look like this. I'll go with the red color, contrasting color, to show that it will be like this, in between the vertical line and the circumference of the small of the large one, right? This. So it's neither the vertical line nor the circumference of the small circle. It should be in between them. Oh wait, I'll put in the middle, right? Something like this. So including with that red line I'm drawing, it's not a perfect circle, no? That red line is not the part of the perfect circle. Okay, I'll stop there. My God. Right, so we have to look for answers like that. Now this is wrong. Why is this wrong? Flat. This one is flat. This is wrong because the circumference continues. That's wrong. The circumference can't continue. Circumference continues. This looks fine to me. Third one should be the answer, no? People, why? There is a push from small sphere to large sphere side, but it is not the perfect circle. Now if you complete that circle, the small one, it should be something like this. No, this is perfect. If you complete the circle, it should go like this, but they have drawn it more towards the smaller circle. No, I mean, yeah, more towards small circle, in sense it's not the perfect circle, right? It's not completely the perfect circle. So I think that's okay. Here again, same problem. Here also same problem. Circumference is continuing. And here, what's the problem, people? Here, what's the issue? Here the issue is going to be this is wrong. This part is wrong. This part is incorrect. Okay, this part is incorrect because it should have been towards the other side, no? Should have been towards the other side. Like this. Should have been like that. That's why it's wrong. So the answer is third. Good. We have done questions like this at the class. Just revise the basic idea. So that's the end of 2018. Now we'll move on to 2000. That's the end of 2018. Now there's another question in 2018, right? For 2019, there is no question because there was a structured essay question. Now talking about 2018, this one so looks a bit scary, but I don't think it's as complicated as it looks. Let's hope for the best. Right. This is the 44th MCQ from 2018. Sorry, I'm waiting, preparing the slides. Okay. When a long capillary tube of uniform bow radius is dipped vertically in a beaker of water of density dW, the water column in the capillary tube rises to a height of h0, as shown in the figure. Now, an oil of density d0 is poured onto the surface of the water in the beaker slowly without disturbing the water, as shown in the figure. Assume that the oil and water are immiscible liquids. Good. The variation of height capital H of water column inside the capillary tube measured from the water surface with the height simple h of oil layer is best represented by. So don't panic, we are supposed to plot a graph for capital H versus simple h. So the sensible thing to do is getting an equation for capital H in terms of simple h. I'm pretty sure it's not going to be very difficult. All right. So for that, we definitely have to analyze the second diagram. Right. And then they have not mentioned anything about the contact angle, people. So when they have not mentioned anything about the contact angle in particular, what we can do is we can take the liberty of taking it as 0 and considering it. If not, we can take it as cos theta also, no problem, I believe. But it might get unnecessarily complicated. So Yeah, never mind. We take it as okay. So adding now remember the contact angle will depend on the type of liquid and the surface, type of liquid and the type of surface, now we are not changing water, people. Water is the one who is going to rise, and we are not changing the surface as well. So contact angle will not change. We'll take it as cos theta. So how do we do this? We can take this point as now the pressure at this point is pi, right? Pressure at this point is pi. Pressure at this point is PA, and we'll take the pressure at this point as PB. If I take the pressure at this point as PB, I can take the pressure at this point also as PB, people. Correct? Because these two are 2 points in water at the same horizontal level. PB, PB. Good? Right. And then let me start off this way. Since they have not mentioned anything about contact angle, right now, okay. So if I take the contact angle to be theta here, then we know in the capillary tube, we don't have to go this far, but right. In that capillary tube, this is the meniscus, and if this is going to be the radius of the tube, and capillary, I mean radius of, what do you call that, radius of curvature of the meniscus is capital R. So this length, this small length here, it's going to be simple r, the radius of the tube, simple r and simple r, the small length, you can see, yeah, simple r and simple r, and this angle is theta. That's the contact angle. If this angle is theta, then this angle is also theta. You should have done this. You should, we actually did this in our theory class. So we know the relationship between r and simple r. Capital R is equal to, simple r equal to capital R cos theta. Okay, so capital R is equal to simple r divided by cos theta. That is the radius of meniscus, radius of curvature of meniscus. Who? Capital R. Simple r is radius of capillary tube, internal radius of capillary tube, but yeah, internal radius of capillary. This is a quick revision. We don't have to bother about all these things because all these things are going to be constant. So I'll go with capital R. Capital R is going to be a constant because these two are constant. Simple r is the radius of the capillary tube. We are not going to change it. Theta is the contact angle. Contact angle will depend on the nature of the liquid and the nature of the surface. Both are not changed. So that is also going to be constant, right? That is the relief now, people. Then let's get started. For this meniscus, let me apply the pressure difference equation, that is delta P equal to 2T over simple r. What is delta P? Pi minus PA. This is PA. Pi minus PA. That is equal to 2T over capital R. Remember, capital R is the radius of curvature of liquid meniscus. We'll put it as number 1. And for PB, there are two equations we can write, no, for PB. One equation for PB is, people, what? Here, this at this point, the pressure is going to be definitely pi. So that is going to be, one equation for PB is pi plus, this is a flat surface, so directly we can say pi plus simple H, this is oil, density of oil is DO, simple H DOG, second equation. And for PB, we can write another equation that is inside the capillary tube. PB is going to be equal to what? PA plus PA plus what? PA plus capital H DWG. So the second equation I have written here, that is, this is for the, from outside of the tube, outside the tube, and this is inside the tube. Okay, so what should I do now? Second and third are same, people, same equation, so I can equate them, second and third, and that will give me an equation like this: pi plus HD naught G equal to PA plus capital HDWG. I have pi minus PA already. So let's make pi minus PA the subject, right? Pi minus PA, that is equal to capital H dWg minus simple H dOg, and I'll take that as a fourth equation. All right, good. So first and fourth are same, and capital H must be made the subject. Let's make fourth equal to first, and the equation we're going to get is capital H dWg, all right, minus simple H dOg equal to 2t over simple r. Remember, the graph has to be plotted for capital H versus simple H. We are almost there. I'll make capital H the subject. So what should I do in the first step? This one goes here side, capital H dWg equal to H dOg plus 2t over r, minus H dOg goes to the other side, becomes plus. And then let's divide everything by who? dWg. I'm going to divide the whole thing by dWg. When I do that, you have only capital H on the left side. When you divide dOg by dWg, you will be getting dO over dW, sorry, dW simple H plus, just divide it 2t over r dWg. Okay, right. So look, we have our capital H here, we have our simple H here. So what does it look like? What is going to be the equation? It looks like y equal mx plus c. Remember, m and c are constants. M and c are constants. Why are they constants? G is missing. Oh yes, G is missing. Where is G missing, Krishnika? Where is G missing? No, right? dOg divided by dWg. G is there, no? G is there. Here with dOg, when you divide dWg, G and G will get cancelled out. So we have y equal mx plus c, and m and c, they are going to be constants. Why are they constants? Because the other quantities are constants, people. Other quantities are constants. I mean, dW. So we do by equating the pressure points also, we can do. That's what I have done here. I have equated the pressure points. What else have I done? This pressure and this pressure equal. That's what I've done here. So what is the answer, people? Now listen. Now, when you have an equation like this, you will not always get the fourth one as the answer. We have to make sure gradient is constant. Then only you will get a straight line. So dO is density of oil, dW is density of water. They are not going to change it, right? They are not going to change. Sorry, they are not going to change. That's right. Okay. I get your point now, Yusuf. Yusuf is asking, what if we just take the pressures directly? But will it work that way? No, I don't recommend that method. No, I don't recommend that method. Whenever you see capillary tube, always consider surface tension. Now, it might work for this question, right? It might work for this question like we do in mechanics. But if there's another question with capillary tube, sometimes if you do it that way, you might be in trouble. So whenever you see a capillary tube, it's better to focus that on focus that with surface tension. Yeah, it will work. You will get the answer, but that's not the correct way of doing it. You might get trapped in if there's another question, and then you can't say, I tried it that way, I didn't get the answer. So whenever you see capillary tube, but I understand your point. You can save time without going through all this trouble. I don't know, man. What if they had asked about the other things? And here we have H naught. No, why have they given H naught here? Wow, the H naught is also given. 2t over r. 2t over r is supposed to be capital R, no? Right, okay. 2t over r is supposed to be capital R. Yeah, capital R here, sorry. And yes, of course, this 2t over capital R dWg is of H naught. This, okay, that is the equation for H naught, yes. This is our H naught. So that's why all the graphs are starting from H naught. All the graphs are starting from H naught. Right. So we can settle to fourth answer. We can settle the fourth answer. But even if you don't know surface tension, I think still you will be able to get the answer, just like Yusuf is saying. Yeah, that's fine. But I wanted to give you the perfect explanation as to what's happening, because in future sometimes you might have to analyze like this, and you might have want to know what is the gradient, you might want to know what is the intercept and all those things. Who knows, right? Okay, now people, right? And you can even do it as an experiment. They might give this as a structured as an experiment. You can use a what do you call that, traveling microscope to measure these heights. You slowly pour oil without disturbing water. Slowly you pour oil and you change the height of oil. And for capital H and simple h, you can plot a graph, and from that graph you can in fact find capital T using these data. Right, fine. Anyways, hope you guys understood this. Answers fourth. Looks a bit intimidating when you see the diagram and everything, but it's nothing. It's just a simple thing. So I hope this explanation helped you revise the concepts of surface tension, the pressure difference. Why third wrong? Why is third wrong? Anyone? Can someone tell me why third wrong? Why is third wrong? Third is a curve, right? When will we get a curve like this? So we have done physics for two or little more than 2 years. So you should know why this is wrong, why this is wrong, and when will we get this answer? When will we get this answer? Can someone tell me when will we get this answer? That's the same thing, right? Second or third, okay, when will we get this answer, people? We will get an answer like this when the gradient is increasing, and we will get an answer like this when the gradient is decreasing. But here the gradient is constant, no? dO dW, therefore the graph has to be a straight line. We'll move on. Then next question, right? Okay, what about this one? This one I think we discussed, no, people? Which of the following is not a result of surface tension? Can we answer that quickly? Quickly tell me the answer. Which one is that? Which of the following is not a result of surface tension? Not a result. Formation of spherical water droplets, yes. Wherever a liquid surface is formed, it will be surface tension. This is surface tension. Capillary rise, just now we discussed surface tension. Ability of insects to walk on water surfaces without sinking, yes. If something is not sinking, there is no upthrust, so it's surface tension. The excess pressure inside the bubble, of course, again surface tension. Escaping of water molecules from water surface, that has nothing to do with surface tension. They are trying to mention the word water surface and try to confuse you, but escaping of water molecules happens because of energy, the water surface, and getting to that has nothing to do with surface tension. Surface tension is responsible for the formation of liquid surface. So in the first four, liquid surfaces are formed. Therefore, answer is fifth one. Done. We'll move on to the next question quickly. Right, here we go. Fifth one. So this is one of the applications which was discussed in the previous question. An insect walking on the surface of water. Right. What is this about? Due to surface tension 0.07 Newton per meter of water, certain small insects are able to walk on water surfaces by pushing down the water surface. The feet of insects can be considered to be approximately spherical as shown in the figure. When an insect is stationary on a water surface, the position of a leg is shown in the figure. Radius of the circular cross section of the spherical foot at the water level. Here they have given it as R. The mass of insect is 5 into 10 to the power minus 6 kilogram, and the radius is simple R. This simple R. This is not the radius of the sphere. It is the radius at this point. I mean, wherever that contact is there will be a circle like this, horizontally, people, like we discussed earlier. So that horizontal circle has a radius of simple R. That's what they are saying. And along that circle only, the force is going to be created like this, in this direction. The force is going to be created along this theta. Like this. This is how force will be created. Like this. Hope you can understand the diagram. Think of that in 3D, please. This is how force is created. Okay, no, I hope it makes sense. Did not draw on the other side. Hope you get the point. Okay, I will not make it too complicated. This is how it is. So the question is, what is the value of cos theta? If the weight of the insect is supported by its 6 legs, the value of cos theta. So on each leg there will be a downward force acting, What is the downward force, people? That is the weight, 1/6 of the weight. The entire weight will not act on one leg, no, people. So that is going to be mg, I'll say mg by 6. Hope you can understand that. The insect has 6 legs, right? Where is that? I hope I saw that somewhere. Here. 6 legs. So each leg will carry a force of mg by 6. To balance that that force, there should be a upward force created F. And what is this force F? That is the force created by surface tension. Vertical, or no, force created due to surface tension. That's a total force. Total force, it will be created along this circumference. Now for equilibrium, what should I say? For equilibrium, I should say upward force equals downward force. The upward force, people, careful now, it is F cos theta, because it is acting at an angle of theta. So we have to put the vertical component. The horizontal components will cancel out each other. So this horizontal component is towards right, this horizontal component is towards left, so they will cancel out each other, but the vertical components will remain as they are. And downward force, people, careful, mg by 6. Capital M is the mass of the insect. And for F, according to surface tension theory, surface tension multiplied by length along which the force acts into cos theta equal to capital mg by 6. And they have asked us to take pi equal to 3. That's a good sign. So let's substitute the values. T is surface tension 0.07, and length along which the force acts, it's what? 2 pi r. Circumference, no? Circumference into cos theta, we have to find that. Capital M is the mass of the insect, which is 5 into 10 to the power minus 6 into g is 10 divided by 6. We are still not done. Wow. Okay, so we are supposed to find theta, right? Cos theta approximately, because I'm right. Okay, then we'll substitute the other value, 0.07 into 2 into 3 into r. What is r? 2.5 into 10 to the power minus 5 into cos theta equal to 5 into 10 to the power minus 6 into 10 over 6. Let's get rid of certain things. Here I have 2.5 into 2. People, this 2 and 2.5 can be simplified with this 5. I have 10 to the power minus 6 into 10. That entire thing can be cancelled out with this 10 to the power minus 5. Alright, so you can do the simplification after this. Up to this only physics. After that it's just maths. Cos theta, after that cos theta. Listen, we have to find the approximate value. So cos theta is equal to, what else is left, people? On this side there's only 1 over 6. So only 1 here, divided by, here I have 0.07 into 3, yep, into 6. Good. 1 over 18 into 0.07. If not 0.216, that is 1.26. Yeah, this is almost equal to 4 over 5. How do I know that? 100 over 126. It is 100 over 126. It's almost equal to 126. It's almost equal to 100 over 125 now, people. That is 4 over 5. Almost equal to almost equal to 4 over 5. So it is almost equal to 0.8. Approximately. Remember, yeah, approximately. Yeah, for the answer is 5th one. That's all. So I think in this question, what is very important is this part, cos theta, and this dividing by 6. Each leg will withstand 1/6 of the weight. That's why I put it this way. Each leg will withstand 1/6 of weight. Right. Yeah, this picture is showing one leg. The force is acting on one leg. Yeah, obviously, this is one leg. They have told, right? They have mentioned somewhere. Haven't, yeah. The feet of insects can be considered to be approximately spherical. So this is one of the legs. Okay. Right, I hope you understood. If you have any doubts, please do feel free to share your questions in the chat so that I can clarify that. So here, now here it's again that equation we use T into length, surface tension into length. Force created due to surface tension is equal to surface tension into length. That concept. Done. And move on to the next one. So we are done with 2015. This is a really interesting question, people. This is from 2014. Right, question from 2014. Because when you do these questions one by one, you will realize that we are covering every theory part from each of these questions, because most of the questions are not identical, no, they are different from one another. Okay, so let me start with this 2014 36. This three spherical liquid films of surface tensions T1, T2, T3, right? They have different surface tensions, so that's something we have to be really careful about. T1, T2, T3. All right. Respectively are in equilibrium as shown in the figure, that such that the corresponding radii R1, R2, R3 are simple R, 2 R, 3 R. Then we have to find the relationship between T1, T2, T3. Okay, people, now they have closed here now. They have closed here and there is air here, remember. This is air. This is a liquid film like soap bubble. Similar to soap bubbles. Okay. So what we have inside them is air. So if I take the pressure here as P, what is the pressure everywhere? If you take the pressure at this point as P, here also pressure is P. Here also pressure is P. So inside here, pressure is P. Here also pressure is P. Here also pressure is P. Understood? And what is the outside pressure? It is open to air, atmospheric pressure. Outside, atmospheric pressure, atmospheric pressure. Please tell me if you understood that. Pressure at all the points, pressure at all the points inside a volume of trapped air are equal. That we have learned under gas laws. Okay, that will be equal, huh? Will not change. Whatever the pressure you have here, 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 because it's air. The same air is flowing everywhere, same pressure. So people will quickly finish this off. We can write the equation like this now. Change in pressure is equal to 2, not 2T, careful, 4T, no? 4T over capital R. No? So for the first diagram, if you apply, it is going to be P minus pi equal to 41 over R1. That is also equal to 41 over simple R. First equation. For the second scenario, we can again write P minus pi. Same internal pressure, same external pressure, equal to 42 over R2. And that is 42 over 2 simple R. I'll leave it as it is without simplifying them. Because on top, same second one. And then the third one, again, P minus pi. Because inside, it's the same pressure, it's the same air volume. Yeah. Outside, it's at atmospheric pressure, 43 R3, but R3 is given as 3 simple R. So it has to be 43 over 3 simple R. That is the third equation. What is common about first, the three equations, people? What's common about the three equations? What's common about the three equations is that they all are equal to each other. They all are equal to each other. 1 equal to 2 equal to 3, because look at the left side. So P minus pi, P minus pi, P minus pi. So that is 41 over simple R equal to 42 over 2R equal to 43 over 3R. I think we can get rid of that 4. Gone, gone, gone. Do we have an answer to this, people? And simple R as well. No, simple R is also cancelled out. So ultimately, I'm getting an equation like this, which looks like what? T1 equals to T2 over 2 equals to T3 over 3. Fifth one, no? Fifth. Yep. Fifth one is the answer. See? So I think in this question it's identifying P to be equal is the most significant part. If you take this as P1, P2, P3, then you will be trapped. It has to be P because it's a trapped air. So in a volume of trapped air, every point will have the same pressure, people. And it's open, no? It's open. So we have learned in physics and even in chemistry, when you have open, bubbles or like this, then definitely bulbs, the pressure will be same. Done. So answer is fifth. Good, then we'll move on to the next year, that is 2013. This one, guys, I have this experiment I have explained on YouTube. Okay, I have done this experiment, recorded it, and I've shared it on YouTube. I'll share the link with you. Okay, so you watch it, and I have explained why the answer is. So once we watch it, I think you will get an idea about this. This is an experiment, small experiment, right? So you can watch it and decide. Right? This one should not be difficult, people. What is the answer? It's in Sinhala, but hope you can understand what they're asking. They're asking for the contact angles. So they have given the contact angles as theta A, theta B, and theta C. Contact angle, hold on. Contact angles are given for each scenario. So please tell me the answer. For this, they have given it as theta A. For this, they have given it as theta B. For this, they have given it as theta C. I think we just discussed about this today in the theory class. This part should be like this. Printing error. Okay, tell me. Which one is the answer? When there is no capillary rise and if it is looking flat like this, what is theta? Your theta B is definitely equal to 90. Definitely equal to 90. Theta B is 90, not 0. Theta B is 90. 0 means it will be a perfect hemisphere. It will be a perfect hemisphere. And what about this one? Here theta A is of course an acute angle. Theta A is an acute angle. And theta C, sorry, this is theta C, okay? Theta C is going to be an obtuse angle like Mercury. So it should be between 90 to 180. Okay, then what is the answer? Third one, people. Third. I think we can be content with the third one. Yes. Third one, good. Done. Simple. Then this question. Oh yes, this is another good one. That is from 2012. Again, that equation, that is force equal to surface tension into the length along which the force acts. That equation. A water layer exists between the bottom of a cylindrical bottle and a glass plate as shown in the figure. The radius of the bottom of the bottle is r. When the bottle is raised slowly at one instant, the contact angle between water and the bottom of the bottle becomes theta. They have indicated that. The magnitude of force of the bottom of the bottle at that instant due to surface tension, is it? Due to surface tension, I think. Here. Capital T is the surface tension. The magnitude of force on the bottle on the bottom of the bottle at that instance due to. Okay, so how do I mark the force, people? I have to be a little careful. The force has to be marked along the contact angle. So this is the force. Like this, the force will be like this along the surface, right? So when you take components, who will get cancelled off? Horizontal components will get cancelled off. Now when you say f cos theta, it is going to get cancelled off. Now people, so resultant force is going to be equal to f sine theta downwards. F sine theta downwards. Why? I can say the reason for that is this, because horizontal components cancel out each other. All right, good. So people then tell me the equation. That's it, finished. For F, what should we substitute? For F, we have to put surface tension into length along which the force is acting into sine theta. And for length, what should I put? Just like the previous questions. Here, this is a bottle, cylindrical bottom. So 2 pi r is the length into sine theta. I mean, if you want me to draw the diagram a bit more elaboratively, then we are looking at a diagram like this, bottle, which is kept like this. This is how the bottle is kept, and the way the force acts is this. Wait, this is how the bottle is kept, and we have a water surface which is created at the bottom like this. Yep, like this. So there's going to be a force which is going to act along this line like this. Hope you can remember, we drew diagrams previously as well. This is how the force is going to be created downwards, like this. Hope you can understand how why it's slant, because this force will act along that surface like this. Yeah, and it will act here as well, people, don't forget. Perfect, vertically down like this. That's why the length is 2 pi r. See the force act. Sorry, I think I lost my connection. Huh? Can you hear me now? Yeah. Can you hear me now? Hello? I think we have, yeah, right. When did I get, I hope I got this answer before I lost my connection. I got this answer, right? Did I get the first answer before I lost the connection? Please confirm. Okay, right, fine. So let's go on to the move on to the next question. That is 2000 question from 2011, right? 2011. 2011. Right. So 2011. We'll do this quickly and move on. This is another right. Let's read carefully. Spaces between the nylon fibers of an umbrella. Nylon fibers of an umbrella made of nylon cloth could be considered approximately as cylinder. Screen is not shared yet, is it? Okay. Is the screen visible, people? Okay, wait, looks like I have a technical error. Wait.